Annyeong. That's hello in Korean, for those of you that don't know. I know a couple words in Korean. That's one of them. It's actually kind of slang. But anyway, 3-2, we're looking at what we call direct variation. It's a very exciting topic. Our Common Core State Standard is ACED2. Create equations in 2 or more variables, graph equations, and coordinate axes on coordinate axes with labels and scales. Okay, so here it says the time it takes to hear thunder varies directly with the distance from lightning. So you've probably heard that before. You count how from when you hear the thunder to when you see the lightning, and then it's like that many miles away or something like that. Anyway, this is called a direct variation, this relationship. Now, a direct variation is a relationship that can be represented by a function of the form y equals kx. Okay, so it's kind of like y equals mx plus b. But notice there's no b. And basically they just changed the m to a k just for fun. Not sure. Just because it's direct variation, I guess. But really they're the same thing. K is like your slope here. So anyway, the constant of variation for a direct variation, k, is the coefficient of x. So by dividing each side of y by x, you can see, so if we get divide by x here, is basically what they're saying. Divide by x, got our squiggly line. Ka-chow. We get k equals y over x. So if you want to find your constant of variation, you just have to divide y by the x. That's basically what it's trying to say. Okay, so looking at this problem down here, this says, does the equation represent a direct variation? If so, find the constant of variation. So if you get y by itself here, we just divide this by squiggly line, divide by 7, ka-chow. We get y equals 2x over 7, or 2/7 x. And it does look like the y equals kx. So this is a direct variation, yes. And in this case, k would equal 2/7. Now this one, if we get y by itself, squiggly line, we have to subtract the 4x first, because they're on the same side, minus 4x, ka-chow. So then I get 3y equals 8 minus 4x, and to get y by itself I have to divide by 3. So divide by 3, divide all that by 3, so I get y equals 8 minus 4x over 3. Okay, that does not look like y equals kx, so that is not a direct variation. So that one is a no. That's a no-go. Alright, you can also see that this has a constant number with it, this 8 right here. There's no variable attached to that. Whenever you have that constant, that's affecting your y-intercept, so that's changing. This is more of a y equals mx plus b equation. Okay, so you can't have just a constant number like that for a direct variation. Because notice on this one, we just have a 7y and a 2x. So if you just have y and x with their coefficients, then yes, it's going to be a direct variation. If you have that constant there, it is a not. You can't just have the 8. Alright, next. Okay, does this represent a direct variation? So in this case we do have a constant here, but the constant is 0. This 0 here. So if I solve for y, I get 5y equals negative 4x, because I subtract 4x, divide by 5, divide by 5, cancel, I get y equals negative 4/5 x. So this is a direct variation, and my constant, you can say k, or if you want to say m is fine, my constant's going to be negative 4/5, because that's the coefficient of x, once we get y by itself. So get y by itself, then whatever is attached to the x will be the constant of variation. Alright. To write an equation for direct variation, first find the constant variation k using an ordered pair other than 0, 0. So let's look at this. This says, suppose y varies directly with x. When y equals 35, x is 5. What direct variation relates x and y? So basically, we can look at these two things. Y equals 35, x equals 5. Because we know it varies directly, we know it's going to look like this. Y equals kx. So I can just plug this in and solve for k. So I plug 35 in for y. I don't know what k is yet. X is going to be 5. To solve that, just divide by 5. So then I get k equals 7, or 7 equals k. So then what equation can we use? Well, we just write it as y equals kx, so y equals 7x. And if I plug in a 5, 7 times 5 is 35. So this is our equation here. What is the value of y when x is 9? So then I plug in 9, so y equals 7 times 9, which is 63. So when x is 9, y is 63. Okay, you could also use proportions to solve this, because direct variations are proportional. So I could have said 35, I'm going to do y over x. So 35 over 5 equals, I know x is 9, so y over 9. And then solve your proportion by cross multiplying. So 35 times 9, divide by 5. And you should get 63 again. So you can do that. You can also just plug it into the equation, whatever floats your boat. Okay. So I'll go ahead and try this one. I'm going to let you try this in 3, 2, 1, pause. Alright, welcome back. So we get k equals negative 5 here, and which means y equals negative 5x is going to be our equation. And if I plug in x equals negative 15, which is this part right here, I get 75. Negative 5 times negative 15 is positive 75. Negative times negative is positive. Hip hip hooray. Alright. Okay. Space exploration. Ooh. Weight on Mars, y, varies directly with the weight on Earth, x. The weights of the science instruments on board the Phoenix Mars lander on Earth and Mars are shown. So, what is an equation that relates weight in pounds on Earth, x, and Mars, y? So, the equipment weighs 50 pounds on Mars, but it weighs 130 pounds on Earth. So, we know that this one is y. Which one's y? The Mars is y, so we have our y here, x here. So our constant of variation, since it varies directly, is going to be y over x, which is 50 over 130. Simplify that fraction and we get, those zeros cancel, we get 5/13. So what is an equation? Well, it's going to be y equals 5/13 x. Okay, if you want to figure out what you weigh on Mars, just plug in your weight on Earth here. So y equals 5/13 times whatever your weight is, and that's how much you would weigh on Mars. Congratulations, you just lost like 50 pounds probably, I don't know. Then what is the graph of the equation in part A? So your graph, if we have our y and our x. So if you weigh 0 on Earth, then you're obviously going to weigh 0 on Mars. So all these direct variation problems should start at your origin like this. Okay, and then basically I just use my slope, so 5/13. So I'm going to go up 5. Just say that's 5 over 13. That's 13. I don't know why it looks 13. Okay, and then again it's linear, so it's going to fall in this straight line pattern. Hey, that was a pretty good straight line. Okay, so it should look something like that. So you just use your slope or your constant variation, so go up 5 and over 13. That's what the graph looks like. Whoops. Next. Okay, so go ahead and try this one. This one talks about the moon. Ooh, the moon. All right. I'll let you try this one. Go ahead and pause this in 3, 2, 1. Pause. All right, so if you weigh 100 pounds on Earth, you weigh 16.6 pounds on the moon. So even lighter than Mars, I think. So our equation should be y equals 0.166x, because we have 16.6 over 100, or you can leave it as a fraction like that if you want. We usually don't like to write decimals and fractions combined though, but it's fine. So either of those equations work, and then again the graph should be a straight line going through the origin, so I'm not going to graph that again. But look at B here. It says, what is the slope of the graph y equals 0.38x in problem 3? Well, the slope is going to be this part right here, 0.38. How is the slope related to the equation? So in problem 3, let me just go back. Our 50 over 130, that's what ends, if you divide those, that's what gives you the 0.38. So basically that means you, for every pound you weigh on Earth, you weigh 0.38 pounds on Mars. Okay, so if you weigh 100 pounds on Earth, you weigh 38 pounds on Mars. So that's what that means. Alright, graphs of direct variations. Okay, so I've kind of talked about this already, but this is the graph of direct variation is a line with the following properties. It goes through 0, 0, and the slope is k. So all of these go through 0, 0. This is a positive slope, this one's a negative slope, on the left and the right. You can rewrite a direct variation equation, y equals kx, as y over x equals k. When a set of data pairs x and y vary directly, y over x is the constant of variation. Okay, so looking at these tables here, we know that these are all direct variations because, well, actually it's asking, does y vary directly with x? If so, write an equation for the direct variation. So to test that, we need to find k for all these points. Remember, k is just going to be y divided by x. So let's find k here. So this one's going to be 6 divided by 4, which is 1.5. This is going to be 12 divided by 8, which is also 1.5. This is 15 divided by 10, which again is 1.5. So is it a direct variation? Yes, because they're all the same. And our equation would be y equals 1.5x. Okay, now look at the next one. Let's find k here. This is going to be 3.2 divided by negative 2, which gives us negative 1.6. This is going to be 2.4 divided by 1, which is just positive 2.4. And then this is 1.6 divided by 4, which is like 0.4. So this one is not, because all of your things are different here. So this is not a direct variation. So this is different than finding the rate of change. Okay, so we're not finding the rate of change here. So you're not looking at the change here, because this goes up 4 and this goes up 4, blah, 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 blah. So you're not looking at that. You're actually just looking at the actual x and y values and dividing them. Okay. So before, when we're doing slope, you're looking at the rate of change, so seeing how much they go up. This one, you're just dividing y by x to find the constant of variation. Okay, so this one's not a direct variation on B, but A was. Okay, and last one, I'm going to let you guys go ahead and try this. Pause this in 3, 2, 1, pause. Alright, so if you looked here, I kind of went backwards because I don't have room on the right, but y divided by x, all of these should give you negative 0.75. So our constant of variation is negative 0.75, and we get y equals negative 0.75x. That's our equation. And that's all for today, folks. Hope you enjoyed this wonderful lesson on direct variation. Catch you on the next one. Annyeong. That also means goodbye.